Today we will be covering multiplying binomials. It is one of the most fundamental operations you need to understand for any algebra course, any high school math course. So if you're not sure what a binomial is, specifically we're talking about what are known as algebraic binomials. So two terms where one of them is algebraic, meaning it has a variable. So we'll start with this example. Very classic intro to algebra example where you have a sum, x plus 7, and you're finding the product of that and another sum called x plus 3. Now, what can be confusing is once you enter algebra, it usually comes down to you trying to solve for x when you're solving an equation. But we're not solving an equation. We are simplifying an expression. So if someone says, hey, simplify this expression, they just want you to multiply the two binomials. So previously, I've talked about a method that you could use for multiplying two-digit numbers, and I'm just going to revisit that idea now. We're going to revisit that method known as the grid or the box method. If you were to look it up, I've seen it called both of those two things. So how would we start this? Well, what's actually happening, just to speak quickly, is to do this correctly, you would have to apply what's called the distributive property, which says that if you're multiplying two terms times two terms, each term must multiply the other two terms. So your x term would multiply, right? The x term in the first binomial would multiply the x term and the 3 in the second binomial. And similarly, your 7 would multiply the x term in the second binomial and the 3. So some people have no problem doing this and they can keep track of their multiplication. However, just to add a method that could help, let me show you another way we can tackle this. I'm going to create a little grid here. And my grid's going to help me organize my multiplication. So one of my binomials I'll put on the top, so like x plus 7 on the top. And on the side, I'll put x plus 3. So those are my two binomials I'm multiplying. And in the grid, it's going to handle all my multiplication and keep my products separately, or keep them separate until I find the sum of my product after it's all simplified. So, okay, you start with x times x. X times x is known as x squared. X times x is called x squared. Positive 7 times x on the right here is 7x. 3 times x on the bottom left here is 3x. And then a 7 times 3, multiply the constants, that's 21. So once you find all the products here, then your answer you're looking for is to correctly combine all these terms. So to correctly combine all these terms, we have to do what's called combining like terms. So if you're unfamiliar with combining like terms, we're trying to collect terms that have the same variable factor. So my x squared term that you see here, this x squared term is unique. There is no other term in this sum that has an x squared, sorry. So my x squared term has no like terms to combine with. Now, if I were to highlight my other terms separately, so if you look at the 7x and 3x, 7x's and 3x's makes 10x when you add them. An example I use is, if you have trouble thinking about adding variable terms, just think of them as a real life object. So 7x plus 3x might be a confusing question to you, but what about 7 dogs plus 3 dogs? That's just 10 dogs, right? And then lastly, we have a constant term of 21, and no other term in my sum has no variable. So 21 is a unique kind of term. And this would be the product. X plus 7 times x plus 3 is x squared plus 10x plus 21. There's no more simplification necessary since all the terms are of a different variable expression, right? We have our x squared term, we have an x term, and a constant term. All right, let's look at another example. And we'll do it the same way. And some of us might not have any issues with multiplying all positive terms, right? Positive terms might not give us a headache. However, obviously, if you've been in algebra long enough, you know that negative numbers are going to find their way into any problem you deal with. So if I were to create the box method for this problem here, 2x minus 5 times 3x plus 4, I'm going to use my same method here. So we have 3x plus 4. We'll just put that on top. It doesn't matter which one you put on which side, right? 2x minus 5 goes here. Now, that might be a little confusing the way I wrote it because the minus might look a little weird on the grid there, so I'll just put a minus 5 there because it is a -5 term, right? So let's go and start multiplying here. All right, so again, you might need a little more pre-information to go along with this video. If you really struggle with multiplying terms, you might have to seek out a little help with that first. But anyways, in this top left box, we have 3x times 2x, which you multiply all the factors, and you multiply the factors that can multiply together. So 2 times 3 is 6, so you can multiply 2 times 3 is 6, and x times x is called x squared. Top right here, we do 4 times 2x, so 4 times 2 is 8, so that's an 8x term. On the bottom left, we do have 3x times a -5. So remember that 5 is a negative term. So 3 times -5 is -15, and that's an x term. And this is why I actually really prefer the box method or the grid method. When I have students do the distributive property, let me show you up here. When students know that they have to distribute 5 like this, a lot of times they kind of miss that 5 is actually a -5. So the box method or the grid method kind of forces you to make sure you understand what kind of numbers you're multiplying before you even set up the problem, right? I had to set up my negative here on the 5. And lastly, 4 times -5 is -20. So I'll kind of do the same thing I did before. I'll kind of organize my terms. I'll highlight in yellow my x squared term. So I only have one x squared term again. I'll highlight, we'll go with like this light blue for my x terms. And I won't highlight my constant term, as we already know it's the only term that is constant. And let's see what this gives us. So I have a 6x squared term. And now we have 8 and a -15x, or a -15x plus 8. So 8 minus 15. Some people might have problems with this. There's no shame in grabbing a calculator or hopping on desmos.com if you've never used that resource. Great calculator. -15 plus 8 or 8 minus 15 is the same result. It is -7x. And then my constant term at the end is -20. And the way that you know you're done, right, is every term has its own unique variable expression attached to it. So my 6x squared is an x squared term. My -7x is an x term. And the 20 is a constant term, the -20. It's a constant term, doesn't have a variable attached to it. So these are all unlike terms, so there's nothing else to do. So my simplification is complete. So 2x minus 5 times 3x plus 4 is 6x squared minus 7x minus 20. Lastly, I do want to cover a product that might catch some of us off guard. This expression is a tough expression because we all know that squaring, or we should know that squaring means to multiply by oneself, right? X squared means x times x, 5 squared means 5 times 5. But 6x minus 1 squared, it's kind of easy to think of it as something much simpler than it is. It's not just as simple as squaring the terms inside the binomial. You actually have to square the binomial itself. So what I mean by that is we'd have to rewrite this. This actually means 6x minus 1 times another 6x minus 1 binomial. This is a binomial times a binomial. You cannot just multiply or square the terms inside the binomial. We have to multiply the binomial times itself. So I'm just going to go ahead and go back to my grid to help me organize my multiplication. Same as before, I have a 6x minus 1 and a 6x. And I know on the side here, you have to be a little careful. Just remember that that is a -1 term. All right, here I go. So 6x times 6x is a 36x squared, right? 6 times 6 is 36. X times x is x squared. That's my term. On the top right here, a -1 times 6x is -6x. On the bottom left here, a -1 times 6x is another -6x. And lastly, a -1 times a -1 does make a +1, so +1. And then lastly, we just combine all these terms to get our simplification. All right, I'll do some highlighting again. I got my x terms here on the corners. And then in yellow, I'll go ahead and highlight my x squared terms. So again, I like using highlighting if I have it available. It's just so I can like make sure I categorize which kinds of terms are going to combine with other kinds of terms, right? So my x squared terms should only combine with x squared terms. My x terms should only combine with other x terms. And my constant term, the 1, doesn't have any other constants to play with, so it will not be added to any other terms in my expression. So here I go. 36x squared is 36x squared, nothing to combine it with. Negative 6x's and negative 6x's is negative 12x's, right? A lot of my students struggle with what happens when you add a negative to a negative, or what happens when you subtract a negative from a positive, or right, all the different rules we have to remember. But the easiest way to think about this is just think of it as you have 6 negatives and you have 6 more negatives. So when you add negatives to negatives, you get more negatives. So 6 negative x's and 6 more negative x's gives you 12 negative x's. And then lastly, we just have our constant term 1. And again, we know we're done when we have our expression and all my terms have their own unique variables and none of them share the same variables, right? I have 36x squared, no other term has x squared. I have a negative 12x, no other term just has x as the variable. And I have that plus 1, which is the only term without a variable. And that's how you multiply binomial expressions.